Now, ladies and gentlemen, let's come to our next talk. From high gloss to matte effect in a matter of seconds. It sounds too good to be true. Well, it can be true, no way. The method of making ink appear matte was developed more than 20 years ago. So we have to talk about that.
Okay.
Volker Seck is again with me here in our studio. So first of all, I think we have to talk and explain generally, what does Excimer, first of all, stand for?
Okay, it gets a bit technically now. Excimer is actually a common wording for a special lamp type, but in reality the wording is an artificial word. It's a combination of excited dimer. An excited dimer means an electrically excited pair of molecules, which is brought back into its original stage. It emits photons. Photons is nothing else than light.
Okay, get it.
And this light can be used for various kind of applications like surface activation, cleaning, matting of a surface, and that's what we are talking about.
So is matte the new high gloss?
Yes, for sure. I mean, we see a lot of matte products in the industry, in the market. I mean, we see matte cars, we see matte mobile phone packages, but there is also the possibility of having a combination of high gloss and matte, which I really like because that's what the eye is linked to.
Yes, exactly. This is true. Do I need a special chemistry?
Yes and no. A normal, ordinary UV coating works fine for the matting process. It absolutely works, but very often those products have additional requirements like haptics, like, let me say, resistances, and all that may have an impact on the formulation. So we clearly recommend to talk to the coating supplier and us together in order to ensure a perfect solution which will match at the end of the day the requirement.
So what about the setup of such a system? How does it look like?
The setup of an Excimer system is unfortunately not just the Excimer unit. It is very often a unit which we call a pre-gelling unit. Pre-gelling means the coating material himself is irradiated by UV, normally by an LED UV system, in order to get a different viscosity. By doing that, you can adjust the surface properties. Then the Excimer system comes, which is doing the matting, and then we have the final curing by the means of the final UV lamp system.
When we talk about Excimer, we also have to talk about another term. It's called inertization.
That's your favorite term.
Yes, it is. No, it's not. Have you ever heard about this? So please explain us. What is it?
Inertization basically means replacing the oxygen which we have in the ambient air. Inertization is used in many industrial processes. For example, packaging of food to make it fresh for a long time. Fire protection, many things like that. In the radiation curing industry, inertization is usually used to improve the polymerization process. On an Excimer system, it's absolutely mandatory because the wavelength, 172 nanometers, is absorbed by ambient oxygen. That would mean if we wouldn't have the inertization in a very decent way, the Excimer would give the irradiation, but nothing would happen down on the substrate.
Okay, get it. So another question, which speeds can be achieved, generally speaking, for matting our surfaces?
My usual answer depends. It depends really on various things. I mean, we are treating with Excimer wooden materials, paper, foil, film. So it is the machine which has an impact. It is the coating technology which has an impact. Just to give you one clear answer, at least, on foil coating, for example, where matting is very typical usage, we talk about speeds of 2 meters per second or 120 meters per minute.
I think the audience can work with this answer. So thank you very much for giving us this overview. And now, ladies and gentlemen, it's time for Fares and Hida again. In our application laboratory, they show you how the Excimer technology works.
Thank you, Maxi.
Thank you.
I'm Hida.
I'm Fares.
And we both work at the application lab, and today we want to show you our Excimer technology. Before we start, we want to explain how the Excimer lamp works by showing you an example. The lamp consists of a quartz glass which is filled with a dimer gas, and it contains an electrode. The other electrode is located on the outside of the quartz. The quartz acts as a dielectric barrier. When applying alternating voltage, the dimer gas gets excited, and when falling back, it emits specific radiation. In our case, 172 nanometers. And this wavelength gets absorbed by oxygen. So ozone can be formed, and we want to avoid this by using nitrogen. And our prechelation unit is height adjustable, like Fares is showing us.
It's going down.
Yeah, and we can operate this unit with or without a quartz glass screen.
Yeah.
Okay.
Let's go to the main conveyor. Here we have a nitrogen nozzle to blow off all the oxygen before entering the chamber. Then we have two small excimers, which can be used to do overlap trials, so they're adjustable in position. Here we have the station where we can measure residual oxygen or ozone levels, which is also adjustable in the position. And here we have the big excimer. We also have a high power excimer, for example, for cleaning trials. And here we have the station for the post-cure. We can have a maximum of 2 post-cure units, which can either be inerted or non-inerted. Here we have a second nozzle and a third nozzle.
Now we're going to take you on a journey through the Excimer unit.
So thank you so much for this backstage view into your laboratory.